Good day, ladies and gentlemen. We are back again with vertical projectile motion, and on this lesson, we are now going to focus on now the type of projectile that is now bouncy, and then we'll just take a look at this example here that is given to us, and then through this example, we are going to now look at the ways in which we can approach this type of a projectile problem, where now we have now a bouncing projectile. Now let's without any waste of time, ladies and gentlemen, get into this projectile of ours. Now it says here, a ball is projected vertically upwards with a speed of 15 meters from the top of the edge of a building. Then the ball hits the ground after 5 seconds. It is in contact with the ground for 0.3 seconds and then bounces vertically upwards, reaching a maximum height of 8 meters. And then it says they ignore the effects of friction. It then tells us now that this is a free fall motion, right? Ladies and gentlemen, if you can agree with me, in order for us to solve this projectile motion, what we need first is that we need to draw ourselves a trajectory, because now I can see that this projectile of mine was thrown or was now projected vertically upwards with a speed of 15 meters from the top of the edge of the building. So I will then start with my building there, and then I know that from my building I will then have a ground here. I will have a ground there, and then the ball was projected vertically upwards from this edge. It means now the ball was at this edge, and then it was projected upwards, and then we know that if it is projected upwards there, it will now go up until now its velocity reaches 0, where we said that this is a maximum height, and then eventually we know that the ball is going to come back, and then it's going to hit the ground there. And this is similar to the type of motion in our previous video there. But what is now interesting about this one, what is interesting is that now the ball hits the ground after 5 seconds and is in contact with the ground for 3 seconds. And then what is very, very interesting, which will be now our topic, our focus for today, it now is that now the ball bounces. Then this ball of ours, it's going to bounce there. This ball of ours is going to bounce, and then it reaches a maximum height. It reaches a maximum height there of 8 meters. Of 8 meters there. So you'll agree with me from the previous video. We then said it is very important to label our motion. So I will have my point A there, my point B, my point C, my point D, and then here lastly I will have now my point E. You agreed that we must now label our trajectory. Then it says to me, can I talk about the velocity of this projectile or of this ball of ours at every point that I've mentioned there? Yes, we can talk about that. If we talk about that, we'll say now that the velocity at A, we know it. The velocity at A, we know it. that it is 15 meters per second. And then we can also now talk about the velocity at B, that this at B there, that is our maximum height. We know that at B it's maximum height. We know that from our previous video, and you'll agree with me that the velocity there at B is equals to 0. And then we can also talk about the velocity at C. As you can see that at point C, the ball is exactly where it was as it was thrown vertically upwards. So you'll agree with me that the velocity there is now equals to 15 meters per second. I have not yet chosen my direction. Hence, you see now I've just put in the magnitudes, not the directions yet, but we'll go into the directions after choosing our positive direction. Now we're just talking about the magnitudes. Then at point D there, what is the velocity there? The velocity at point D, we don't know. We don't know the velocity at point D, but there's so much that we are going to talk about at point D there. So let us leave it as a question mark like that, because there is so important information that we are going to talk about there. And then at point E, what is it that I have at point E? What is the velocity there? I know that point E is the maximum height that they talked about, and then they said that now there is a maximum height of 8, and also I know that at maximum height, this is max height, because now the ball bounced. Now at maximum height, I know the velocity at E must also be equals to 0 meters per second. 0 meters per second. Now my interest is now on point D I mean. Now at point D, remember this ball was going in this direction, downwards. So we have now the velocity at D. We have two velocities there. The velocity at which now the ball hits the ground with. That is now when the ball was going down. And also at point D, there's another velocity that the ball leaves the ground with. So at point D there, there are now two things that we must focus on. Is now that the velocity at which the ball hits the ground with, and the velocity that the ball leaves the ground with. And you'll agree with me that this velocity that the ball hits the ground with is greater than the velocity that the ball leaves the ground with. We'll talk about that in a few moments. Let's now look at other information that we have. They said now it is in contact with the ground for 0.3 seconds. So as you can see here, there is now, this is what we call now the contact time. This is the contact time, and the contact time there is 0.3. And then if I talk about the contact time, you'll now remember that we talked of the contact time when we were doing now the impulse and momentum theorem. So we know that at point B there, that's where now the ball is going to strike the ground. The ball is going to strike the ground with a force, and because these two are in contact, the ball is going to exert a force on the ground, and the ground is also going to exert a force on the ball. And then given this contact time here, the examiner can further say, oh, go and calculate the net force. Go and calculate the net force. And we know how to calculate the net force from a impulse and momentum. So we'll look at that as we get to that problem. So it then says to us again here that the ball hits the ground after 5 seconds. So from A up until D, the ball took about now 5 seconds. It took 5 seconds for the ball to hit the ground. So if I've done this trajectory of mine, then I say, examiner, I am ready for your questions. Give me your questions. I will answer your questions. Then the first question that the examiner can ask can say now, calculate the number one, let's say now the height of the building. The examiner can say, calculate the height of the building. Calculate the height of the building. Now, if the examiner wants now the height of the building, it then says, I must go back to my trajectory. And then in my trajectory there, I can see that the height of the building, it's this portion. The height of the building, it's this portion which is CD. It's CD, ladies and gentlemen. You'll agree with me. We saw that from the previous video. But depending on the information that I'm giving, someone can choose to work with the motion from C to D. And when you are working with the motion from C to D there, you now don't have the time from C to D. You only are given now the time from A to D. But we can find that time, ladies and gentlemen. Now, let's divide this question of ours in two ways, because there are two ways in which we can answer this question. Someone can choose to work with motion from A to D, because if I look from A to D, what information do I have from A to D? I have the time from A to D, which is 5 seconds, and then also I have now the V initial at A, which is 15 meters per second. And then also, what is it that I have? I have G. Remember, I always have G, which is 9.8 meters per second squared. And remember, I only need 3 variables to solve a problem. Now, with that being said, let's choose now our positive direction. If I choose my positive direction, I will then say, let my upward be positive, meaning that my downward motion will be negative. And if that is the case, can I assign the direction to all these vector quantities? The velocity at A, remember from A, the ball is going upwards. So if it is going upwards there, my velocity at A will be positive, and then my velocity at C will be negative, and then my velocity at D. My velocity at D, because we said we have two velocities at D. The velocity at which the ball hits the ground with. When the ball hits the ground, it was on its way down. So when it's on its way down, you'll agree with me that when it's on its way down and up is positive, there it must be negative. And the velocity at which the ball leaves the ground with, this, it must now be positive, because when it bounces, it will now go upward, and then upward is positive. And then let's now assign here. We said A must be positive, and then G must now correspond to this choice of direction of ours. If down is positive, if up is positive, down must be negative, and we know that G acts downwards, so it must be now negative. And then from there off, I have three variables, and when I look at my formula sheet, the formula that I can use there will be this one that says now delta y is equals to v initial delta t plus half a delta t squared, because now this formula of mine has delta y, and delta y will now give me the height of the building. So I will say now this is the height of the building, to say now is equals to, what is my v initial? What is my v initial? My v initial, we said it is 50. And then my time we said we are taking the motion from A to D, and the time from A to D is 5 seconds, plus half A, which is represented by G there, it must be negative 9,8, and then I will have now 5 squared. And then when I insert that in my calculator, I will say now 15 multiplied by 5 plus half multiplied by negative 9,8 into 5 squared. And then I will find my height of the building there to be a negative my delta y, I mean negative 47,5 meters. But the examiner did not ask me to find delta y. I will then say, therefore height is equals to 47,5 meters. Then that will now be my height. Remember, this ball was going up, and then as you can see, for me to get this delta y to be negative there, as you can see, the height of the building, it's now the same as now the points from C to D. And then if I were to find delta y from C to D, I will find that my delta y will be negative, because from C to D I'm going downwards, and I chose my downwards to be negative. But the examiner did not ask me to find delta y, he just asked me to find now the height. So that will be now my height. But someone can choose a different approach. To say, let me work with the motion from C to D. Okay, it's fine. C to D. Now, working with the motion from C to D will then say to me, I have the velocity at C. Which is now a negative 15 meters per second. And then what else do I have? Do I have the velocity at D? No, I don't have the velocity at D. Then if I don't have the velocity at D, it says now, obviously I have this G, which is negative 9,8 meters per second squared. I I now have how many variables? I have 2 variables. I need now the last variable. Now, in this particular case, with this problem, the last variable that I can find there will be now the time from C to D. Can I find that time? Yes, I can find this time from C to D. But how will I find that time? Let's have a look, ladies and gentlemen. We said the ball takes 5 seconds to move from A to D. It takes 5 seconds. But now, if I can find the time from A to B, I know the time from A to B is symmetrical to the time from B to C. We talked about that in the previous video. So it now, working with the motion from C to D, it then requires me to go and find the time from A to B. And then after finding that time, I know that time will be equal to the time from B to C. And if I have the time from A to C, I can then subtract it from the total time, which is 5. It's a bit of a work, ladies and gentlemen, but it's not a problem. There are so many ways now to kill a cat, right? So it says to me, when I want to work with this motion from C to D, let me first find the time from A to D to B, to the maximum height. So when I want to find that, I now know the velocity at A is plus 15 meters per second, and I know the velocity at B is equals to 0, and I also know this variable, which is G, is negative 9.8 meters per second. And then I have my 3 variables, and then looking at my equation, I will then have to say VF is equals to VI plus A delta T. Remember, this delta T, ladies and gentlemen, it's from A to B. So the final velocity is 0. The initial velocity will be 15 meters plus negative 9.8 delta T from A to B. And then when I transpose that, it's going to be negative 15 is equals to negative 9.8 delta T. Remember, ladies and gentlemen, when we are looking for time, your time must always now be positive. Your time must always now be positive. So I can see that my time will be positive. So when I divide by negative 9.8 both sides, and then I take my calculator to say negative 15 divided by negative 15 divided by negative 9.8, I will find my time from A to B to be equals to 1,5306,122,45 seconds. This time, ladies and gentlemen, it's the time from A to B. But we know that the time from A to B is equals to the time from B to C. We talked about a symmetry there. To say now, if that is the time from A to C will be equals to the time from A to B plus the time from B to C. And then it's just now 1,5306,122,45 plus 1,5306,122,45. And then the time from A to C will be equals to, now just multiply there by 2, will be equals to 3,06122,449 seconds. This is the time from A to C. And then from there, to find the time from C, D will be equals to now the time from A to D minus the total time A to D minus the time from A to C, meaning this time there. If I can subtract that time there, I will get now to say what is the time from A to D? 5 seconds minus 3,06. So the time from C to D will now be 5 minus the answer there, which is now 1,93877555. Wow. So the time there, ladies and gentlemen, it's going to be now that value there. And then using this time, I can now go and use this equation. Delta y is equals to v initial delta t plus half a delta t squared. And then from there, I know my v initial there. We said it is negative 15, and then the time is 1,93 plus half negative 9,8, and then 9,13 squared, and then the time there, and then I will find my delta y to be, let's say, negative 15 into the answer plus the half of 9,8 into this, and then I must not forget to square there, and then I get the same value of negative 47,5 meters, and then therefore the height, ladies and gentlemen, will be equals to 47,5 meters. So we can see now our answers are the same there. Our answers are the same.